which is on vestigial sideband, that is called as an VSB. So these are my learning outcomes. At end of this session, students will be able to define vestigial sideband modulation and the demodulation techniques. So now we'll start with the theoretical part of an vestigial sideband here. So vestigial sideband is a part of an amplitude modulation. Just we need to recall what is an amplitude modulation and what are its types and what are their applications used in the communication system. So we'll see now the amplitude modulation is the technique used in electronic communication generally for transmitting the information via a radio carrier wave. Means what? In amplitude modulation, we are going to change the amplitude of a carrier signal with respect to amplitude of a modulating signal, and by keeping the frequency and phase constant. Okay, so that is the definition of an amplitude modulation here. So the various amplitude modulations are there, that is amplitude modulation with full carrier, DSB-SC signal, that is the double sideband with the suppressed carrier, and SSB, that is the single sideband with suppressed carrier, VSB, ISB. So VSB are particularly used for transmission of TV signals here. So we are going to look the application of VSB also. Okay, so now we'll start with the VSB, that is the vestigial sideband. So vestigial sideband modulation is the process where it is a part of the signal called as a vestige is modulated along with the one sideband here. So as we know that the much power is required to transmit an AM wave in which you are going to transmit the carrier signal also. So the carrier signal doesn't contain any information. That's why so the 1/3 of the power is wasted to transmit the carrier signal. So that's why we go for an DSB-SC signal. So in DSB-SC signal we suppressed the carrier and we send the two sidebands. But as we know that in the two sidebands we have the same information. So for particular applications where the power is reduced to a half percentile, that is only one sideband is sent, that is known as an SSB here. Okay, but in the some part for the VSB, so what we have said, that is the signal called as an vestige is modulated. Means what? The one sideband is transmitted with along with the other sideband with the small part of the sideband here. Whole sideband is not transmitted here. So why we have to do this? So we'll see in the application of an VSB here. Okay, so this is the block diagram for the generation of an VSB modulated signal here. For the generation of an VSB modulated signal here. So this will be the modulating signal, means the information signal which you are going to transmit here. Okay, so this will be the baseband amplifier which is given to the balance modulator. And as we know that for the balance modulator we required two input signal, that is one is your carrier signal as well as one is your modulating signal here. Okay, so as we have given the two inputs here, as the balance modulator will generate an DSB-SC signal, that is the double sideband band with suppressed carrier. Means what? Here we are going to get only two sidebands here. But as what we have told in the previous slide, that in VSB we are going to transmit only one sideband with along with the some part of the other sideband here. Means we have to design such a filter in such a manner that only one sideband and the remaining half part of the sideband is going to be sent for the VSB signal here. So that's why the name of that filter is VSB. It's like an low pass filter and the high pass filter. In low pass filter we know that only low frequencies are being transmitted and other frequencies are going to be blocked here. In the same manner, so whatever the frequencies we are going to pass for the second sidebands, only those filters are allowed to transmit those frequency and all other blocked here. Okay, so in this manner we are going to generate an VSB signal for the transmission of an TV signal here. Okay, so why we have to go for, so we'll see now. So before that, So this is the spectrum of an VSB. So we know that how much bandwidth will be required to transmit an VSB signal. So as we know that if you see the FM bandwidth, means AM bandwidth, so in AM, so you require two FM signal here, two FM signal. Okay, for DSB also you require two FM signal. For SSB only there is a reduce in the bandwidth, that is the only FM signal is used here. So in the same manner, what we have seen here, one full sideband we are going to transmit and only the half part of the LSB is sent here. So as shown in the spectrum diagram of an VSB, so we have shown here either you can going to send this part or this part along with the one sideband here. Okay, so from this, if you calculate how much bandwidth is required to transmit an VSB signal, is that bandwidth is equals to FM, because we are going to send one sideband, plus the half part of the vestigial sideband we are going to send. Only this part of the sideband is going to be sent here, so that's why we have taken as an FV here. So the bandwidth required to transmit an VSB signal is FM plus FV. So FM is your message bandwidth and FV is the width of an vestigial sideband here. Okay, so we have seen the bandwidth requirement for an VSB signal. Now if you want to demodulate that VSB signal, that VSB signal is taken into the as an input to the product modulator, and as we know that we have to reinsert the carrier signal at the receiver side, so that's why we required an carrier oscillator. So the product modulator will multiply these two signals and generate the signal which is going to be passed through a low pass filter, because the message signal whenever you are going to transmit that according to the modulation, so it is always a low frequency signal here. So we need to transmit only those frequencies and reject all other frequencies. So at the output of this VSB signal we required the low pass filter here, and you will get here the original signal of an VSB here. Okay, so these were the techniques used to generate the VSB and demodulation of an VSB signal here. Okay, so now we'll see the application of an VSB. So this is an application of an VSB for the TV transmission signal here, for the TV transmission signal here. See, as shown in this figure. Okay, so for sound carrier, for the transmission of an TV signals, you require an FM modulation for an sound, and for video, for the picture carrier, you require an AM here. Okay, so you require an AM signal here. Means here two types of modulations are used to transmit an VSB. For sound carrier we are going to make use of an FM, and for the picture carrier you are going to make use of the AM signal here. Okay, so as per the International Telecommunication Body, so for the transmission of an VSB signal for the TV signals, they have given us to transmit only the bandwidth of 6 megahertz here, 6 megahertz. So in that only we need to transmit an VSB signal here. But as we know that if you calculate the video carrier, that is the picture carrier, is being modulated at 4.2 megahertz here, that is the 4.2 megahertz. But as we know that this is the 4.2 megahertz is used for the transmission of an video carrier, so the bandwidth required for that AM station for the AM signal will be 2 FM. So it will be 8.4 megahertz will be required to just transmit the picture signal here. Again there is a sound carrier here. It is approximately how much, 9 megahertz. It is approximately 9 megahertz here, but the bandwidth available to transmit an AM signal is of 6 megahertz only. So to reduce this bandwidth, so what we have done, we are going to send only one part of an sideband and some part of the sideband here. So that's why your reduction will be there at 6 megahertz here. Okay, so that is the reason behind that we are going to send only one sideband, whole sideband, and some part of the sideband here. if the information is also lost here, because the information will be contained same in your both the sidebands here. So if this information is lost in this sideband here, then what happen, you can take the information from this sideband here. Now we'll see the bandwidth here. See, as shown in this here, this is the relative channel frequency, which is often 6 megahertz here. So this is the picture relative amplitude. This is a picture carrier. So video upper sideband is 4.5 here. So as we have discussed here, 4.2 we have taken, it requires 8.4. So that's why by reducing the sideband, we are going to get it into 6 megahertz here. Okay, so this is the application for the VSB used in the television here. Okay, for the TV transmission. So we'll quickly revise what is an VSB. VSB is the process where the part of the signal is called as a vestigial is modulated along with the one sideband here. Okay, and its main application is to transmit an TV signal here. And in VSB, both the modulations are used. That is, the for transmission of a video signal, AM modulation is used, and for the transmission of the sound, we are going to make use of an frequency modulation here. Okay, so these are my references. Thank you.